What's up, you guys? In this video, we're going to be talking about square root functions. So we've already talked about these some. Um, words, they're escaping me, I'm sorry. But we talked about the graph of it. So as far as the graph of this goes, the square root parent function, don't forget that the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So we have a square root function going something like that. That would be our parent function. Now, the other thing that they're going to start bringing up is something that is the inverse of this. So the inverse, remember the inverse means that we switch the x and y exactly where they are. So don't forget that this is like y equals the square root of x. So if I were to switch the x and y exactly where they are, I would have x equals the square root of y. So now to get y by itself, I would square both sides. So I would square both sides so that y equals x squared. Well, that's just a parabola. But the thing we need to pay attention to, see how this, it kind of looks like a parabola, right? There's our square root parent function. Zoom out just a little bit. That's not out. Come on, camera. Come on. All right, so that's a little bit better. But this is our square root. Notice it's like a parabola, but it's only like half of one, right? And that's not even right. But also, for a inverse function to exist, must pass the horizontal line test and the vertical line test, so we're good there. But to find the inverse, you can switch the x and y exactly where they are. So let's see. The point of this is 0, 0, so if I switch them, it's still 0, 0. So that'll stay there. The point here is 1, 1, so if I switch it, 1, 1 still stays there. Now this point, 4, 2, if I switch that and make it 2, 4, so 2, 4, I'm plotting the inverse. This was 9, 3, so if I switch it, it becomes 3, 9, so 3 and 9. So check it out. What it does is my parabola, but notice it's only half of one. So what you're going to start to see is restrictions on the domain. So the way that this is written is y equals x squared. And notice we only had like the positive x values. I didn't go anywhere where I had negative x values. So what we say, as long as x is greater than or equal to 0, is it the inverse of the square root? So I would have the parabola, but only the positive side of the parabola. If I were to graph the negative side, think about it. These two things are inverses of each other. Right? Inverse, inverse. If I were to graph the other side and make it the whole parabola, it would fail the horizontal line test. So, not the inverse of that function. All right, moving on. Let's see what else we got. So here, what is the domain of each function? So this is going to take you back to the first semester where if we're moving stuff, I think it was Unit 4 that we did all of this, don't forget that this is our square root function, right? So we have something like that. And this minus 3, since it's inside with the x, it does the opposite of what you think. So this is going to move everything to the right 3. So since I'm taking this graph and I'm moving it right 1, 2, 3, I still hit there and I'm going up in that direction. So that means for the domain, the x values must be greater than or equal to 3. That's it. You could also see this in interval notation, from 3 to infinity, always from least to greatest. Moving on. What is the domain for this function? Right, so we're doing this. So again, here I have a x plus 4. So instead of moving it to the right 4, it's going to move it left 4 since it's in the x, and it does the opposite of what I think. So if it moves it left 4 from this 0, 0, then I'm going to be at 1, 2, 3, 4, and I'm going to be opening in that direction. So I'm going, x is greater than or equal to negative 4, or from negative 4 to infinity. And don't forget too that the brackets mean that is included. That's actually hitting at that point. Parentheses, never put brackets around it. All right, moving on. So next two, we have what is the range of each function. So still doing the same thing, but notice this is not inside with the x anymore. This is on the outside. My square root stops right there at the x. So what this does is it affects it in the y direction. We do exactly what we see, and we're going to move our function up by 3. 1, 2, 3. So now it's opening like that. So I would say for the range, since the range is affecting the y values, y is greater than or equal to all of my values at 3. Yes. Okay. Next one, minus 5 on the outside, so that's going to move everything down 5. Right, so I'm going to take my function, move it 1, 2, 3, 4, 5 down, and it's still going to be opening in that direction. So it's still opening up. So my range will be y is greater than or equal to -5. I could also see it in interval notation, -5 to infinity, since it's going up forever. All right, so we have determine how to obtain the function from the square root parent function. So all this is meaning is it going to vertically compress? Is it going to vertically stretch, horizontally compress? What is it going to do? So don't forget the square root. All that means is that we have the square root of x. There's no like pluses, there's no minuses, there's no multiplication, there's no negative signs, nothing like that. So we're just looking about what is the graph going to do. So again, inside with the x, it's going to do the opposite of what you think. So instead of multiplying my x's by 2, I'm going to divide them by 2. So it's going to compress horizontally in the x direction by a factor of 2. Then that minus 4 is on the outside, so it's going to move everything down 4. That's it. All right. 1/3 of the x. So instead of dividing by 3, I'm going to multiply by 3. So I'm going to stretch. Stretch horizontally by 1/3, I'm pretty sure is what they say. And then that plus 6 on the outside is going to move everything up 6. With this next one, I have a 3 on the outside, so it's going to affect the y directions, and I do exactly what I see in the y direction. It's only the x's that you do the opposite. So I'm going to multiply the y's by 3, so I'm going to vertically stretch by a factor of 3. And then that minus 7 on the inside is going to take everything and move it to the right 7. Oh, that's a 2. 7. Exactly the opposite of what you think. Anytime you're inside with the x, do the opposite of what you think. You don't want to be around your x anymore. That's why you broke up with them, right? All right. Determine the domain and range of each inequality. All right. So these are a little bit tricky. They can be. But notice, we're just taking the square root function. I'm moving it to the right 2 and up 3. So now also, I have y is less than or equal to these values. So if I take my square root function, move it 1, 2, 1, 2, 3, that is my new point, and I know I'm going to be opening in that direction. So now for this less than stuff, get a highlighter maybe. Oh, do I have a highlighter? Yes, I put a highlighter. All right, remember, we cannot take the square root of negative numbers. So kind of our boundary here, what we treat as our boundary, is this box right here. I'm not going to go outside of that box with my shading. So if I go over here, I'm going to be using negative x values. If I go down here, I'm going to have negative solutions. So both of these don't really work. So take the point, go straight out horizontally, go straight up vertically. And those are kind of our boundaries for our graph. So now if it says y is less than, just like when we were graphing lines, if I were to pick a point and I need to be below that point, then I would be somewhere down here. Since I'm down there, I must be below all of those points all the way across. So that is the shaded section that you will see. And it's going right up to that box. And that's pretty much it. That's it. Okay, moving on then. Y is greater than 2x, or square root 2x minus 1. So this is going to horizontally compress by 2 and down 1. So take your square root graph, horizontally compress by 2, so that's going to make it go like this, so it'll look like it'll be a little bit fatter, and move it down 1. So we have something like that. So again, if it helps you to think about straight up, straight out, those are the areas that we can shade. So notice, I kind of messed up in this one, I'm sorry. But it says y is greater than this line. So when we are greater than, we make a dashed line. So make sure this is dashed. My bad. I'm so sorry. So let me just get rid of this. Ignore. I messed up. I'm sorry. All right, so down 1, stretch, and a dashed line. That's more what it should look like. And we have y is greater than in this case. So if I need to be greater than, then I need to be above. So I need to be above, and I'm not equal to, so above would be everything right there. All right. Last one of these. Y is less than 2 times x plus 1. So this moves it left 1. This is y's by 2. So it's also going to, it's taking our function and kind of stretching it out in the y direction. So it's going to grow a lot faster. Also, I'm going to notice that y is less than, so I'm going to draw a dashed line. I'm not going to mess up again. So I have left 1. I have growing faster in the y direction. And then if it says y is less than, I know I'm going to be below all of my y values, so that kind of tells me the area that I can shade. Yay, marker shading time, yes. It's so great. All right, and that's pretty much it for the inequalities. And don't forget, you guys can always type these in Desmos and kind of check the work as well. So check yourselves out as you go, especially quizzes and tests, to make sure you get those points. All right. Using composition of functions, determine if the two functions are inverses. So remember, with composition of functions, that is f of g of x, and we want to show that it equals x. We also want to show that g of f of x equals x as well. So we're going to have to show both ways here. So I'll just write out 2 versions of it, or the 2 forms. I'll draw a line in between so you can differentiate. All right, so this is saying go to f and use g of x. So if I go to f, sometimes this helps. If I say g of x squared minus 3, right? That's going to f, and using g of x as our new x. So if I put in what I know g of x to be, that's the square root of x plus 3 squared minus 3. Well, once I square that square root, it's going to go away, so I'll end up with x plus 3 minus 3. 3 minus 3 is 0. Hey-oh. So I'm left with x in the end, which is exactly what we're looking for, right? F of g of x is x. It is, right? We got x. So now let's make sure that g of f of x is x. You have to check both ways to make sure that this actually works. All right? So doing the same sort of thing, going to g and substituting f of x. So go to g, substitute f of x, so the square root of f of x plus 3. Now I can put in what I know f of x to be, so the square root of x squared minus 3 plus 3. Negative 3 plus 3 is 0, so I'm left with square root of x squared, which is just x. That's good in that direction as well. So now also, think about your graphs. You guys know how to graph these things. So if I were to graph the square root of x plus 3, it would be left 3, and I would have something like that. If I were to graph x squared minus 3, well, that would be a parabola down 3. But, like we were saying in the earlier part, we cannot have that other part. So what is going to happen is your answer choices here, you're going to have to say, yes, they are inverse functions of each other, because f of g of x equals x, or g of f of x equals x, and this is only if x is greater than or equal to 0. That has to be the same in both functions as well. If they have different restrictions, it's not going to be inverses of each other. They're taking different parts of the graph. So be careful of this, because we cannot include that part of the graph. We have to have it only when the x value is greater than 0. All right, moving on one more. So again, still proving they're inverses of each other. So f of g of x, yeah, that's a g of x, and g of f of x. All right. So f of g of x, I didn't want to write it that way. I'm sorry. So go to f, put in g of x, so square root g of x plus 3, and then minus 6 on the outside. And now g of x is all that junk. So square root of x plus 6 squared minus 3 plus 3 minus 6. 0. Square root of x plus 6 squared, so x plus 6 minus 6 simplifies to be x. Yes. All right. G of f of x, so I'm going to go to G, put in f of x, so f of x plus 6 squared minus 3, right? Put it in for the x. And then I can put in what I know f of x to be, solve that. So square root x plus 3 minus 6, plus 6 squared minus 3. Negative 6 plus 6 makes 0. Square root squared just makes that x plus 3 minus 3. So x in the end works out. And again, this is one where notice we have a parabola, but on this one we're also moved to the left 6. So we got to be careful here too. So think about the graphs. This one's moved left 3 down 6. So left 3 down 6, it's going something like that. This one is moved left 6 down 3. So left 1, 2, 3, 4, 5, 6, down 1, 2, 3. So on this one, in order to take only that part, only the positive part of my graph, this part, right, my vertex is happening at negative 6, negative 3. So I need to say the x values need to stay greater than negative 6. So this would be yes, because f of x, keep doing that, f of g of x equals x. This is only true as long as x is greater than or equal to that negative 6. That's what we would be looking for. So zoom out a little bit. Zoom out a little. Right, so our vertex is here. We can't take the negative values, so I have to stop this at negative 6 and only take the positive part of that. All right, please remember whatever questions you guys got, bring it on. I look forward to hearing from you. All right, I'll talk to y'all soon.